Hi, this is Ms. Nickel, and this video is going to be on electron dot diagrams, how to draw them, and how to use them to find the number of covalent bonds a nonmetal element will form. Okay, so when we're talking about metals and nonmetals, what do we mean? We can divide the periodic table into three big categories. There's a lot of smaller categories, groups, and things like that. But for our purposes right now, we're going to classify things as metals. Okay, and so metals is going to be everything here in yellow. I can make a little key for this here. All right, so that is metals. And our metalloids are shown here in green. Those are things that are in between. They have properties of both metals and nonmetals. All those metalloids. And our last category then is our nonmetals over there in pink. All those elements that make up living organisms: carbon, nitrogen, oxygen. And we have our halogens. We'll talk about those. All right, so those are our three big categories. I can write, I don't think I'll write on this area over here. Pink is nonmetals, we'll just know that. Okay, so next thing we want to talk about is that elements that are in the same column are called groups. So columns are groups, so a column goes up and down like that. And the word group, so that's going to equal a column. And it has the word up in it. And that's important because that helps us remember that groups are columns and they go up and down. All right, elements in the same group have similar properties. And very important for us, they have the same number of valence electrons. So same number, valence, and E minus means electron, okay? And that's super important because that is going to allow us to draw those electron dot diagrams. So in order to help me keep that straight, I'm going to number my columns with these numbers inside of boxes, but the only ones I want to number are the tall group columns for the main group elements, okay? The transition metals, which go from here to here, follow a little bit different rules for valence electrons, so we're just going to be looking at the tall group columns. So it's 1 and then 2. We skip over here, 3, 4, 5, 6, 7 is our halogens, a group of highly reactive gases, and 8 are noble gases. Okay, remembering columns go up and down, right? Okay, so all of the elements in the first column, hydrogen, lithium, sodium, potassium, are going to have 1 valence electron. All the elements in the second column are going to have 2 valence electrons. We're going to skip all of these guys. Then everybody in the third column will have 3 valence electrons, and so on. Valence electrons are what we're representing when we draw electron dot diagrams. Okay, so I'm going to show you a piece of the practice test here that we had, quiz 1 practice test, which was on atoms, compounds, and reaction types. Okay, so this would be the part that's on atoms and getting us ready to understand compounds. So right here in part 2, it says draw electron dot diagrams for each of the element symbols shown, then fill in the information in the blanks below. So electron dot diagram is going to show the valence electrons for that element. Okay, so we look at phosphorus. Phosphorus is here. That's atomic number 15. And so phosphorus is in the 5th column, though. That's what we care about, not the row. The row is different. That's energy levels. Column goes up and down. Phosphorus has 5 valence electrons because it's in the 5th column. I'm going to draw those valence electrons. Now, the way I'm going to draw those, let me zoom in here a little bit. Remember I said that it has 5, right? But I have to place them a certain way. And the way I'm going to do that, I just learned this. This is a good way to do it. You make a cross on the element like that, and you're going to put 1 dot per branch of the cross until you have all of them with 1 dot, and then they start to get 2 dots, okay? So this is what I mean. Phosphorus gets 5 valence electrons, right? So I'm going to put them in 1, 2, 3, 4, and then I can start to double them. So number 5 goes here, but now I'm out, and that's all I do. So what I have now is I have 1 pair and 3 single valence electrons. It's like phosphorus had a box around it, and you can only put 1 electron, one electron on each side of the box until you get past 4. Now let's do the same thing with calcium, okay? So I'm going to draw my cross, and I'm going to find calcium on the periodic table. It is, I got to zoom out a little bit here again. Here's calcium right here. You can see that it's in column number 2. Okay, so it's going to have 2 valence electrons. So I go here to calcium, and I'm going to put in 1 dot and 2 dot, and now I'm done. I don't go any further. Those dots are single, they're unpaired electrons, and that's all the valence electrons that calcium has. Next, I go to sulfur. And sulfur is right here in column number 6. It's going to have 6 valence electrons. I draw my cross. In fact, I'm going to draw my cross for all of them right now so I don't have to stop and do that each time. And you don't have to draw the cross. That's just to help you place the electrons. Okay? So sulfur, we said, gets 6. And I put them in at 1 at a time. 1, 2, 3, 4 until I get past 4. Then I start to double 5 and 6. So sulfur has 2 pairs and 2 singles. Next, chlorine. Chlorine is here in the 7th column. So it's going to get 7 valence electrons. And I'm going to put those in. 1. Oh, it doesn't matter which side of the cross I'm going on. 1, 2, 3, 4, 5, 6, and 7. So chlorine has 3 pairs and 1 single, and here it is in the 7th column. Gallium. Let's see, gallium is here in the 3rd column. That means it's going to have 3 valence electrons. I'm going to draw those like this. I'm going to go 1, 2, and 3. Now, it doesn't actually matter which sides the singles are on. Like on calcium, I could have the singles over here, the singles down here, as long as I have the correct number of singles, the correct number of pairs. That's all that matters, not exactly which side they're placed on. Okay, and the last one we're going to do is hydrogen. Hydrogen is up here in the left-hand corner of the periodic table, and I realize now I made a mistake because hydrogen is actually a nonmetal. It's an exception to the placement of the nonmetals. It's up here in the left-hand corner of the periodic table, but it is still a nonmetal. Also, the different thing about hydrogen and helium is that they can never have more than 2 valence electrons. They can't have 8 like all the other elements because the first level that holds electrons is very small and it can only hold 2 electrons. All right, so I'm going to put those in and it's just going to be 1 valence electron for hydrogen. Now we're kind of backtracking a little bit because it's asking us metal versus nonmetal. That's the next question here, metal or nonmetal. And so I'm just going to look at the periodic table, and that tells me whether something's a metal or not. All right, phosphorus was over here, number 15. That's going to be a nonmetal. I'll write non. Calcium is right here on the left side in the yellow. That is metal. So sulfur here, nonmetal. Chlorine, also a nonmetal. Gallium here is a metal. And if it's a metalloid, I'll just tell you now, just choose, what I forgot to show here too is that there's actually kind of a dark line in between these two areas that doesn't necessarily show up on the version I did here, but it kind of goes like this. So some of the metalloids are on one side of it and some are on the other. And so you'll be able to see that on most periodic tables you look at. So if I ask you, say what germanium is, for the purpose of an exercise like this, you would just say that it's a metal, and you would say silicon was a nonmetal, because it just means that it tends more in that direction. All right, but anyway, we said gallium is a metal, and hydrogen, if you remember, is our exception that's over here, but is a nonmetal. All right, next thing I need to figure out is number of covalent bonds. This is a very simple rule to follow if you have done your electron dot diagrams correctly. So the number of covalent bonds for a nonmetal is going to be equal to the number of unpaired electrons or single electrons, okay? And I'm going to draw those in like lines here just to make that really clear. I don't know if I have any better color to do that in. Probably not. I'll stick with green. All right, so phosphorus, first we ask, is it a nonmetal? Yes, it is. It will make covalent bonds. How many can it make? It can make 3. 1, 2, and 3. Why is that? Because it has 3 unpaired electrons that it can share. Each of those unpaired electrons can find an unpaired electron on another nonmetal, and the electrons are shared between the two elements. It's like they were holding hands, each of them contributing a single electron to make a bond. All right, if you remember, covalent bonding elements share electrons. All right, now, next one, calcium. Is it a metal? Yes, it is. So that means it makes no covalent bonds. This was number of covalent bonds, all right? It can bond in an ionic compound. Metals lose, so it would lose these 2 electrons completely. All right, next one, sulfur. Sulfur is a nonmetal over here, so it can make covalent bonds. It has 2 unpaired electrons, 1, 2. So I'm going to put a 2 here for the bonds that it can make. Chlorine has 1 unpaired electron. It is also a nonmetal over here. So I'm going to put the number 1 in there. Gallium is a metal, so we put an X. It doesn't make covalent bonds. And hydrogen, nonmetal over here, 1 unpaired electron. Hydrogen can only make 1 covalent bond. All right, so that the rules for that are really pretty basic. There's just a few key things you have to understand. If you didn't understand something that I went through, replay the video, play that section again, or ask me in class.